Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom, added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6s go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides, and so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. On a scatter graph, an outlier is a point which doesn't fit the pattern, and as we can see here, all of these coordinates fit kind of a nice line going down there, so they all are showing a trend, but we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So in this question we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators, and we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20. So we times that by 4. And so we've got times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees, and always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. the bottom two angles of the isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. The key to estimating is that normally you will be rounding numbers to one significant figure and then working out the answer. So I'm just going to rewrite this fraction here, but instead of 93, we're going to round that to one significant figure, so that'll be 90. We're going to round the 265 to one significant figure. Now, some people will write 270, but one significant figure means the line goes after the 2, and so that would round to 300. Then 31 will round to 30, and 97 will round to 100. Now the next step is to see things that we can cancel here. So we can divide top and bottom by 10 to make that a 9 and make that a 3. We can divide top and bottom by 100, make that a 3, make that 1. And we can divide top and bottom by 3, so that will make that 1, and that will make that 1. And so at the top we've got 9 times 1, which is 9, and at the bottom we've got 1 times 1, so 9 divided by 1 is just 9, so our answer will be 9. To rearrange this, I'm just going to write out the equation again, and I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So Pythagoras says that a squared plus b squared equals c squared. And the c is the one opposite the right angle. So I'm going to label this a and b. So it would be 5 squared plus 12 squared equals c squared. 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is, and we're just going to square root both sides. So square root of 169 is 13, so c is 13. So to find the gradient, we need the formula or the equation in the form y equals mx plus c, and the m there will give us what the gradient is. So we're just going to be rearranging this equation, and so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So when we're asked to find the position, we're basically finding out what n is. And we're told that the sequence has a 39 in it, and we're finding the position of 39. So we're going to equal the nth term to the 39 and solve it. So we're going to put in our solving lines. And the first thing we're going to do is take away 15 from both sides, because we want n on its own. So we get 6n equals 39 take away 15, which is 24. Then we're going to divide 6 both sides. And so we get n equals 4. So 39 is the fourth term in the sequence. And you could write it out. You could put n equals 1, n equals 2, n equals 3. Just keep going until you get to 39. Or we can do the method we've just done, which is solving it. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers, and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually times it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A. And we're going to draw an arc from point B. And you can see that the 2 arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into 2 fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide 2 powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the 2 minuses, the 2 takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40. Which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now, next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600, take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome would be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can times top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. So I'm just going to write this out again, just so we've got a bit more space. Okay, the way we solve this is very similar to solving an equation with equal signs, but this time we're going to do 2 tramlines because there's 3 sides of this inequality. And we need to get x on its own. So looking at the fact that we've got 3x plus, or 3x minus 5, we're going to deal with that minus 5 first. So we're going to add 5 to all 3 sides. So add 5 here. So we'll just leave 3x in the middle and add 5 to the right hand side. Now we need to get rid of that 3. So we're going to divide by 3. And again, we need to do it all 3 sides. So divide by 3 and divide by 3. So we've got x is greater than or equal to 7, and then we've got 10 is greater than x on the right hand side. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times 2 powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. In this question we have a right angle triangle and we know 2 of the sides and we're looking for the third one, so that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So this question is asking us to find the probability of not A and B. So if we look at and I'm just going to quickly draw out a similar Venn diagram. So if this is A and this is B, then not A will be everywhere apart from A. So it would be all of this here. And if we do the same thing again, and this time we're interested in where B is, so we've got A and B, then B is this part here. So if you have a look and see which are shaded in both, you can see that this part here is shaded in both. So this part here is not in A and is in B. So it's this 3 here. So the probability is going to be that 3 over the total amount. So all of these added together, which is 25. First thing I'm going to do is add these column vectors. So we're going to add the tops first. And then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4. And 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So with the power, if the power is at the bottom, if it's got a fraction, then the bottom of that fraction is what we're going to square root or cube root or root the number by. The number at the top is just the power. Now, because we've got a 1 there, it's just going to be power 1. It's not going to really do anything. So we're looking to do the square root of 196, and the square root of 196 is going to be 14, because 14 squared is 196. So we're just going to do the square root of 196, and that's our answer. This question, we're adding fractions. Okay, there's a bit of algebra, but the process is exactly the same as when we've always added fractions. We need to find out what the lowest common multiple of 4 and 7 is. Well, actually, the lowest common multiple is 28, which is 4 times 7. So what we're going to do is multiply the left-hand fraction by 7. So we're going to times the k by 7, which will give us 7k. And we're going to times the 4 by 7, which will give us 28. And we're going to times the right-hand fraction by 4, which will give us 4k at the top. and it will also give us 28 as the denominator. Now when the denominators are the same, we just add the numerators, and 4k plus 7k, or 7k plus 4k, will be 11k, and the denominator will be 28. We've got to first of all work out the equation of the line given to us, and it's horizontal, so it's going to be a y equals line, and it crosses the y-axis at 2.5, so it's going to be the line y equals 2.5. Now there are lots of different inequalities that would involve the line y equals 2.5. We've got y is greater than 2.5, y is less than 2.5, y is greater than or equal to 2.5, and y is less than or equal to 2.5. So we've got to work out which one of these it is. Now when we've got a dashed line, it means it cannot be equal to, so that gets rid of these two. And if we pick a coordinate, let's pick this one here, on our region side, it is 8, 8. Now look at the y coordinate, which is 8. That is actually more than 2.5. So it's not less than 2.5, it's going to be more than 2.5. So it's y is greater than 2.5. I'm going to first of all get x equal to the 0.151151, blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000, and we'll get 151.151.151, blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151.151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number unknown together. So we're going to do 12 times the 6, which is 72. So we need two numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need two numbers that add together to make that minus 17. They need to be the same two numbers. So what we can do is we can write out the factors of 72 and try and find them. We can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative because they add together to make a positive. Sorry, they add together to make a negative, and they multiply together to make a positive. And then just trial and error, just think it through, and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17, we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around. Plus 6. We're going to factorise linearly the first two terms, and we're going to factorise linearly the second two terms. So here we can actually divide out 3x from both of them. And we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation, and to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0, and get our solving lines in. So So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3/4. So our second solution is 3/4. You're expected to be able to draw a sine, cosine and tangent wave. And here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to -1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines. That will not get you any marks. You've got to make it look like a wave. And this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that would definitely get the marks. So I'm going to just write out this formula again. We're 8t plus ut. Now we want to get t as the subject. So the first thing I'm going to do is I'm going to factorise the t's. So t bracket 8 plus u. And what I want to do is I want to get rid of that bracket there. And so what I'm going to do is divide both sides by that bracket. And so we're going to end up with s over 8 plus u equals t. So t is s over 8 plus u, or s over u plus 8. So the way functions work is that they actually queue up, and the function nearest the brackets is the first one to go. So the f will be the first function we look at. So all I'm going to do is just leave the g on the outside and just put a set of brackets down. So to do f of 4, all we do is we feed in that 4 into where x is in the function f of x. So instead of 5 times x, it will be 5 times 4, which is just going to be 20. Now that's the f of x sorted, and we're now going to look at the g of x. The g of x says that it's going to be 3 plus 2 lots of whatever's fed in, and we're going to feed in that 20. So it's going to be 3 plus 2 times the number we're feeding in, which is 20. And 2 times 20 is 40, and then 3 plus 40 will be 43. So our answer will be 43. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is. And that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern. So the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it'd be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. When asked to simplify a fraction, we need to find a factor at the top and the bottom of the fraction to divide out. So we're going to start by factorising these fractions, and I'm not going to go into how to factorise quadratics because we've got plenty of other videos on the site that go into that. But when you factorise the top, you get 3x plus 4 and x minus 5. And when you factorise the bottom, you get 2x minus 1 and x minus 5. Now it's not a coincidence we have the x minus 5 at the top and the x minus 5 at the bottom, because we're just going to divide that out to simplify the fraction. So we're just going to divide that out. That will make that convert it into 1, and 3x plus 4 times 1 is just 3x plus 4, and same with the bottom. So we end up with 3x plus 4 at the top and 2x minus 1 at the bottom. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When asked to simplify a surd, and this actually isn't a surd until we've simplified it, it means to get rid of, or to get the square root as small as possible. And the way we do that is we write down the factors of the 48 first. So we've got 1 times 48, we've got 2 times 24, 3 times 16, 4 times 12, and we've got 6 times 8. Now we want to look and see where the largest square number is. So we've got the 1 there, we've got the 4, and we've got the 16. So the 16 is the largest square number. And so what we're going to do is we're going to rewrite the root 48, but instead of root 48 we want to split it up into square root 3 square root 16. But always put the square number first. So I'm going to write it as root 16 times root 3. Now square root of 16, the reason we put the square number first is we can actually square root that. Square root of 16 is obviously 4. So it becomes 4 times root 3. And with surds we don't actually write the times sign between an integer and the surd. So it's just 4 root 3. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified, so that becomes 2 over root 3, and we're asked to rationalise the denominator, so we're going to times this by root 3 over root 3, and so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. Now notice the format that it wants the answer does not have a square root at the bottom, so we are going to be rationalising the denominator with this. So I'm just going to write out the question, just so we've got a start. And notice here we've got this 6 plus root 2. Now you might think you rationalise the denominator by timesing top and bottom by root 2, and that would get rid of the root 2 there, but it would actually create a 6 root 2 at the bottom, so it won't rationalise the denominator. The trick here is, imagine that the bottom here is a bracket, And what you want to do is times top and bottom of this fraction by the same bracket, but with the different sign, the opposite sign in the middle. So instead of 6 plus root 2, it's going to be 6 minus root 2. So we're going to have 6 minus root 2. Okay? And when we do that, we can imagine that there's going to be brackets at the top as well. We've got 2 plus root 2 and 6 minus root 2 at the top. And then we've got the 6 plus root 2 and the 6 minus root 2. Now, the reason why we do that is you will see when we expand the bottom one, but I'm going to start with expanding the top one. And it doesn't really matter which method you take to expand it. I'm just going to use the grid method because it's a little bit clearer maybe. And so we've got 2 plus root 2, and we've got 6 minus root 2. So 6 times 2 is going to be 12, and that's going to be 6 root 2 minus 2 root 2, and then that would be minus and a positive is a negative, and then root 2 times root 2 is just going to be 2. And so when we add these two together, we're going to get 10. When we add these two together, we're going to get plus 4 root 2. And I'm going to now do the bottom one. So this one was this expansion here, and I'm now going to do this expansion here. And we're going to do it down here. And so we've got 6 plus root 2 and 6 minus root 2. So 6 times 6 is 36. 6 times root 2 is 6 root 2. 6 times negative root 2 is just negative 6 root 2. And then we've got a minus and a positive make them negative, and then root 2 times root 2 is just minus 2. And so when we add them together, we've got the 36 and the minus 2 there, so that would be 34. And then 6 root 2, take away 6 root 2, is just going to be nothing. So that actually expands to be an integer, not a surd. And that's why we picked the opposite sign, is because whenever we do that, we get rid of the root 2, and we just get a nice number at the end. Okay, so when we put those in, and we end up with 10 plus 4 root 2 at the top, which is our answer here, over 34, which is our answer here. And let's just make that a bit nicer. There we are. And that's our answer down here. Now, we're looking to see whether we can cancel at all. And if you look, we can actually divide everything by 2. So divide the bottom by 2, and we get 17. Divide the 10 by 2, we get 5. And we've got to divide all 3 terms by 2, so we get a 2 there. So we actually end up with 5 plus 3, 5 plus 2 root 2 over 17. So our missing numbers, looking back at the question, A would be the 5, B would be 2, and the C is 17. So we're going to just quickly write out our sequence, so 9, 22, 41, 66, and 97. And we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19. So they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth, so 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence, so what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. You can see that there's a negative on the outside of the function, and when we have a negative on the outside of the function, it means that we reflect it in the x-axis. So we're going to be reflecting this graph in the x-axis. We can see it crosses the x-axis here, so our graph needs to go through that point, and we just try our best to reflect it, and so it should look something like this. And we're going through that point there, and then all the way up. A +1 inside the brackets will mean that we're doing the opposite. So a +1 you'd think would move the graph right 1, but it doesn't. It moves the graph left 1. So we're just going to go through each of the points on the graph, and we're just going to shift the points to the left 1. And when we do that, we get something like this. And then obviously we need to join these up with one straight line, which I've already failed at doing. And there we go. So there are many ways to solve a quadratic, but in this question we're specifically told to complete the square. So I'm going to start by just copying down the question. And when we're completing the square, we're interested in the x squared and the x term. And we start by just writing down a bracket with x, and then we're going to add or subtract the coefficient of the x term, half of it anyway. So the coefficient of the x term is -12, so half of that is -6. Close the bracket and write squared. Over here we're just going to see what that gives us. So it'd be x minus 6, x minus 6, and that would be x squared minus 12x plus 36. So this creates a plus 36 we need to get rid of. So we're going to take away 36. Then we've got the minus 20 from the question, and then it's an equation, so we get it equal to 0. And then finally we've got x minus 6 squared. Add the minus 36 and the minus 20 together, and you get minus 56 equals 0. Now we solve it, so we get our lines in, and let's solve this. So I'm going to use all the same colour maybe in the equation now. So we've got minus 56, so we're going to add 56 both sides. If I get the right function, so plus 56 both sides. And that will give us, that will leave the x minus 6 squared on the left hand side equals 56. I'm going to square root both sides to get rid of the squared. So x minus 6 equals, and then square root of 56, we just leave as root 56. And then we're going to add the 6 to get x equals. And that will give us x equals, and then we've got a 6. Now, when you square root 56, you can get a plus or a minus. So it'd be plus minus square root of 56. So my answer would be 6 plus minus square root of 56. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.